Hello, everyone. I'm Ian. Nice to meet you all. Before I get started, I want to do a quick poll. How many folks in the audience, I know we have a lot of founders, how many folks in the audience are actually agent builders, building some sort of AI agent, LLM tools? Okay. So hopefully what I'm about to show will be relevant for all of you. But I realized I didn't introduce myself. So like I said, I'm Ian. I'm head of forward deployed engineering and founding engineer at Arthur AI. We build a platform for agent developers and people who need to govern AI in enterprises to help you get your AI from prototype essentially to reliable and trustworthy in production. What I'm going to show today is what we call the agent development lifecycle, and this is kind of a term we've coined at Arthur about how we build agents from that demo prototype and get them to be reliable in production. And this is akin to the software development lifecycle. I don't know here if folks have heard that term, but this is the same thing, but now applied for AI and agents. And as you can kind of see on the diagram here, there's essentially three phases of an agent development lifecycle. The initial phase is the implementation and scoping, where you define, what is it the AI you're trying to build is going to do? What does success look like for that agent? And importantly, you define your risk profile of how important does this agent need to be, or will it be in production, and how much risk are we comfortable taking before we put it in front of users? So once you've defined those kind of key metrics, you can actually enter what we call the flywheel, and this is where the agent improvement happens. So you think at this point you have your demo, your prototype, and then you enter the flywheel where you identify where the agent is underperforming. You find solutions to those underperformance, and then you push those performances to production and then repeat to get your agent essentially reliable and trustworthy in front of customers. The last phase of this is the discovery and governance piece, which once you have an agent in production, it's crucial that you observe, monitor, and alert on that agent so you find out before your customers do when things are going wrong, or you have a behavior, regression behavior, and things like that. So in the demo I'm going to show you next, I'm actually going to walk through a quick iteration of what this looks like in the Arthur platform and show you guys how you can use the Arthur platform to build reliable and trustworthy agents. So I'm going to quick here switch over to the Arthur platform. And to kind of walk through an example today, this might be a little small. Let me try and make this big for folks in the back. But I have an example agent here today, which is a knowledge agent. So it's hooked up to Wikipedia and can basically ask any question about the internet or the world to it, and it'll give me an answer. So to start off, I'm going to ask just a simple question, what is an AI agent? And what we'll see is this agent is actually going to go off to Wikipedia, search for AI-related articles, fetch those articles, and then give me an answer based on the contents of the response. So not too cutting-edge AI anymore nowadays, but just as a simple example for the demo today, a quick question-answer bot. So now that I have this agent, I've actually gone ahead and completed that phase 1 of the ADLC before this demo, where I've done two things. I've hooked up this agent with observability and tracing, and I've configured a baseline set of evaluations for the agent. So next up, I'm going to quick dive into what those look like. If I switch over to the Observe tab here, and maybe this is a little too big now, what I can see here is a list of all the traces and interactions in my agent. So if I click on this first one, we'll see that question I just asked the agent here. And for those of you not familiar with observability and tracing, you can kind of think of this as like a debugging window into how the agent's thinking and passing context around before it responds to the user. So what we can see on the right-hand side is the input to the agent. So there's my question, what is an AI agent? And at a high level, I can see what the agent responded with. But in this column on the left-hand side, what I actually get is the deep dive of how the agent came up with that response. So we can see this agent actually took 6 concrete steps to come up with this answer. It first templated a prompt. It then called an LLM. It called 2 tools, the first to search Wikipedia and the second to fetch the article. And then it finalized its response by calling out to another LLM before responding to the user with the answer to their question, which we see right here. So at a high level, tracing and observability is a key foundation for any agent builder because you need to be able to understand and debug where your agent's going wrong, where it's misthinking, and where it's hallucinating before you can start to improve it. So the second piece I mentioned now are the automated evals. And you can think of an eval as essentially a judge of your agent. So if you have specific behaviors you expect, it can make sure those behaviors continue, and that if it goes off the rails, you can be alerted in real time. In the Arthur platform, we can see a summary of the evals I have configured up here on the right. And today I have 2 evals set up. The first is that I expect my agent to answer or provide a relevant answer to the question. And we can see this one is passing as we expect. The second eval I have, which is really important for knowledge agents, is that I expect it to cite its sources. So if it pulled information from Wikipedia, I want it to tell me that. I want it to link the article. If it pulled information from my Slack or company database, I want to know where it's getting this information, and it can refer back to where it actually found it. In my example here, this eval is failing. And we saw that in the original chat, it didn't say where it got its answer from. So as an example of how to crank this agent development lifecycle, let's quick investigate how we can start to improve our agent so that way it starts citing its sources. The first step in starting to improve an agent is collecting kind of a corpus of test data you can use to improve and suggest improvements for that agent. So the first thing I'm going to do is start to create a data set here that will serve as kind of my behavior test set. To do that in Arthur is really easy. You can come to trace actions, and I can add that trace from my question earlier directly to my test data set. Let me select this here. And what we can see is then we extract out all the important bits of information from that agent's history, and we can add that directly to my test set. I'll quickly jump over to the data set so you can see an example here. But when I open this data set, essentially we have, as of today, I put some in ahead of the demo, but 13 different examples of questions my users have asked this agent. And so for each of those questions, we can see, what articles were fetched, what the final answer was, and things like that. So we've assembled this corpus of behavior test sets. Now the question is, how do we actually get our agent to pass those evals we saw that were failing in the first step? And to do that, we need to suggest or come up with a better way to instruct our agent on how to answer the user's questions. So today I'm going to open up the system prompt for this agent, which basically tells it how to use Wikipedia and how to respond to users in our prompt playground. So this lets me actually interact with these prompts and try out different versions of it in real time. I'm going to zoom out just a little bit here. And very easily, I can actually create a new version of this prompt. And one thing I want to change in my agent system prompt is we've explicitly told it, respond to the user's question and don't include any other information in your response, which I think is probably why it's not citing its sources. So let me actually edit this system prompt and tell it to be sure to include citations for any answers you provide. So I'm hoping now this will help me or help the agent better respond and better pass my expected behavior evals. So let me save this as a new version. All right. So now we have 2 versions. We have the current version v1 and this new potential better version v2. The question is though, before I just ship this and vibe ship this to users, how do I make sure that this is actually going to make a difference? To do that, we can run actually what we call a prompt experiment. So let me pull this up here. I'm going to quick type in v1 versus v2. I can choose that prompt I just created a new version of and tell the experiment I want to compare 1 versus 2 to judge the improvements. Let's feed in that demo dataset with all those example test cases I made. And then we're going to use our same evals that we saw on the traces to actually score the different prompts against each other so we can see which one performs better. So next up, I'll configure the prompts, which is done automatically for me based on the dataset. And then the last step is I'm just going to feed in the experiment results into my evals, and we can kick off the experiment. So what you'll see as this runs is kind of a matrix of all the different combinations. In the columns here at the top, we have our 2 prompts. So you can see v2 versus v1. And then below those, you can see each eval we're running the prompts through. So in this case, it looks like our new prompt, we get a summary too when it's finished at the top here. So I'll use that to show you the example. But in this case, it looks like the demo prompt has been a slight improvement. Whereas before we saw that our attribution eval failed every single test case in the first prompt. We can now see in the second prompt, we're passing about 30% of those evals. So clearly we've done an improvement here, but we still have some work to do. For the purpose of this demo, though, I'm going to say 30% is good enough. And let's actually ship this new version of the prompt to production, so that way our users can start seeing the citations in the response. So I'll go ahead and open that prompt now. And what I can do is you see the two versions here, V2 at the top and V1 below. We'll notice V1 is currently marked as production. So to ship this new V2 to users, I'm going to go ahead and swap this one over to production. And now we'll see when I actually interact with my demo agent here. Let's ask it that same, what is an AI agent question we saw before. And what we should see now is that we've completed this kind of first cycle of ADLC. And we see in the agent's response, it's now citing its sources correctly here at the end. So it said I got this from Wikipedia, the Intelligent Agent article. To complete the loop, and just to prove that this is working end-to-end, let's hop back over to the Observe tab. And what we'll see here is this latest trace. Now you'll notice both evals are passing as we expect. So a very simple example here of how you can use the ADLC to take sort of any arbitrary agent behavior you don't like, set up evals to score it, build a data set to improve it, and then ship those improvements to production. And we've seen a lot of our customers use this to effectively, one, get a reliable agent, but also two, these data sets and evals you build can serve as a burden of proof to their customers that say, how do I know your agent's going to do the right thing? And they can point to all this and say, with 99% probability, our agent's going to work all of the time. So with that, I want to say thank you. That's Arthur and the Agent Development Lifecycle. Thanks.